You want me to use the hand mic? Wow.
Yeah, I think that's all right.
Okay. That's going to be kind of weird. Okay, can you guys hear me okay in the back? Can you guys see the text on the screen okay in the back? Yeah? Okay. I'm going to assume no response as being a yes. So hi everyone. Hi.
What's going on?
I'm Bobby Johnson. This is Identity 101. If you're expecting a different talk, you may be in the wrong building. Wow, tough crowd. Okay. I am from Olympia, Washington, and I'm a developer evangelist for Auth0. But previous to Auth0, I was an engineer for about 18 years in various companies, doing various sorts of software products. So after 18 years, I kept having managers try to push me into management, which is not something that I really ever wanted to do. I don't like managing people, but I do enjoy teaching. So I decided to give evangelism a try because while there is a bit of a markety kind of aspect to it, I do get to teach a lot, and I enjoy doing that. And I get to travel a little bit, so that's why I'm actually here. I typically submit myself to large conferences, and when I get accepted, I try to look for meetups in that city as well as maybe high school computer programs that I can go and speak to high schoolers as well. And my goal is to do a conference and 3 meetups or high schools. And I was lucky enough to get this one, but not others. It's really hard to find 3 meetups that are kind of clustered together in the same month that want me to come talk. That's actually really difficult. Anyway, but like I said, I'm from Olympia, Washington, which is famous for rain, but you kind of have to redefine what you consider rain. If you think of it as liquid sunshine, you can live in a term like that. Olympia is also famous for Riot Girl Punk, which is good. Explains the blue hair. It's a little faded right now, but and it's also probably best known for Kurt Cobain being the reason Kurt Cobain was the way he was. So that was kind of a bad thing about Olympia. Anyway.
It was a good thing in that he was who he was.
Yeah, he made amazing music, yes. Yeah. And it was a very sad, hooked on heroin man. So in the next hour, I'm going to help you grasp some of the essential identity concepts and jargon, as well as explain some of the fundamental problems these systems attempt to solve. This presentation is not code related. This is big picture concept, right? So no JavaScript, no Perl, none of that stuff. But hopefully by the end of it, if you happen to be working in the identity space or implementing some kind of user authentication, you'll know the jargon well enough to at least be able to do a competent Google search, right? So is anybody in the crowd actually work in the identity space right now? Yes, we got 1, 2, 3, okay. And can we be safe to say that the rest of the audience is at least identity curious? Okay, good. Because this is going to get really boring if you're not curious. Like I said, this talk is intended to be a big picture introduction. The identity space is enormous, and there are many experts that work in the space. So I want to give you, like I said, a reference point of where to start those Google searches or where to start learning about the topics. So some of those topics we'll be talking about are things like OAuth, SAML, JOTs, claims, tokens, and other mysterious beasts that you'll encounter when working in identity. So to set kind of the groundwork, let's talk about the problem first. Right, the idea that you're trying to solve with identity is that you have a resource somewhere, and that resource can be a capability, a bit of sensitive data, or anything that you can do within the realm of computing. And you have a user somewhere that you would like to access that resource in a way that is secure. And by secure, I mean it only allows that user to use the resource in the proper way it was intended to be used. There's not only authentication concerns related in that problem space, but there's also authorization concerns as well, right? So the problem itself is really deceivingly simple. If you look at this diagram, it looks ridiculously simple. You have a user who wants to access a resource, and there are actually several things that are not shown by this diagram that complicate the problem space really quickly and really rapidly. Firstly, the problem space we're talking about is extremely critical. If something goes wrong, it goes catastrophically wrong. Think 1.4 million euros wrong. Like it's career-endingly wrong if a data breach occurs in your company, right? Thanks to GDPR, by the way. That's a reference to the new GDPR law that everyone's been panicking about. If you've been on a website in the last year, you know what GDPR has done to us, right? Little pop-ups that make you agree, right? But to Facebook, it costs money. So, next, resources are complex, and in consuming those resources, we exist in a world where everything is programmable and everything has an API exposed, and those resources can be accessed by a large variety of devices. You know, not only your computer, but they can be accessed by your phone, your watch, your thermostat. I was at Home Depot a couple months ago looking at refrigerators, and there was one there that could tweet. I have no idea why I would want a refrigerator that could tweet, but I'm sure it's a security concern, right? Finally, the accounts we use to access those resources exist in an incredibly wide variety of sources. Users can come from businesses and enterprises or enterprise directories. Users can come from social networks and media logins. Almost everyone has a Facebook or a Twitter or a LinkedIn. You have at least one of those three. Anyone not have one of those three? No, see. Okay. So users can even come from an entirely custom-based solution where independent software vendors or startups like build their own login mechanism and wrap their own business rules around it. So it's just completely custom to them, right? Now consider the Cartesian product of all of those sources of users and all of those sources of resources, and you start to realize that the problem can become complex really, really quickly if you're trying to support all of them, right? Also consider that developers implementing these things in organizations are not typically experts in the space, right? I asked people how many where I worked in the identity space. We had 3 out of this entire group, right? Most of you guys are fixated on wanting to build features. So whatever it is your company does, you're wanting to crank out features for them. You're not interested in getting a PhD in security, right? So we can start attacking the complexity in isolation, attempting to brute force a solution that addresses every possible combination of the aforementioned Cartesian product. While that is technically possible, it's probably physically unfeasible. There are far too much to address and still actually build a product at the same time, right? Of course, this is not a new problem. Managing access to resources has been with us since our old neckbeard ancestors first built computing platforms, which I'm slowly turning into one over time. One way the industry has tackled this complexity was to develop protocols defined by open standards. Open standards are essentially an agreement or a set of agreements that different players in the space develop while determining the canonical standard way of describing authentication and authorization transactions without exposing the details of any of the implementations of the various artifacts. And what I mean by that is if you're using an open standard to communicate between 2 systems, you don't need to know that this system is built in Ruby and this system is built in .NET, right? The open standard handles the translation for you, is the idea. These standards define roles that each of the artifacts can play. You have resources that consume identities, you have identities that provide, or you can have identity providers that are the custodians of user identities, keeping track of credentials and similar things. Finally, you can have transactions that join those 2 spaces together. For instance, a user can go to any identity provider and present proof of authentication to a resource. Accomplishing anything without open standards will require intimate knowledge of the implementation of every part of the platforms we want to use, and each one of those platforms might do things slightly differently, sometimes significantly differently, and I'll have a good example of that later. Having open standards allows us to follow a highly prescriptive protocol that describes all the way down to the bits we send on the wire, which will enable us to decouple ourselves from the implementation details of the things we do not control. It's another way of stating what I said earlier. Someone can tell us that they have a resource that uses standard X. We immediately know how to go and go about interacting with that resource without having to know if it was written in Java, Rails, Fortran, COBOL. Okay. There's going to be a lot of lame jokes. You guys are going to have to work on the Okay. All right. Okay. So some of the standards I'll cover in this talk, and that you'll hear about in general when working in the identity space, are OpenID Connect, which is an authentication protocol. OAuth 2, which is a delegated authorization protocol. And if you guys get nothing out of this talk when you walk away, besides that distinction, I will have achieved my goal in coming here. Right? Remember, OpenID Connect is about authentication. OAuth 2 is about delegated authorization. And I'll have a really good example about that to cement it in your head later on in the talk. Right? And another one that is still around and it's somewhat dated, but it's still relevant because governments, universities, and financial institutions have widely adopted it, and that's SAML. Right? So the best way to kind of raise your level of knowledge in this space is to kind of talk about how all of these technologies evolved over time and kind of where we started and how we got to where we are today with things like Twitter logins and how each one of those things kind of added something on top of the other that wasn't capable of happening before. And the next thing that kind of popped in maybe wasn't capable of even being thought of until those two things were combined and they were available to us, right? So let's take a historical tour and see how the industry evolved the various standards from the most pedestrian and simple to the most modern protocols. We're going to start in the enterprise. So when I'm talking about these scenarios, I'm strictly talking about like software that's being developed inside a company that's predominantly for like the employees that are working within that company or maybe partners that work with that company as well. The back half of this talk, I'll talk about the open internet itself and how that evolved. So I'm going to start in the business and then I'm going to talk about the public internet. And these, yeah, that's what I just said. Okay. So here I have a user and an application. The application can truly be any application. Here I'm using a web application because probably we all understand the basic semantics of a web app. You can think of it as being any resource that a user might want to access. Think about the application and what it's trying to achieve. Is it Amazon? Am I trying to buy something? Is it an expense system where I'm trying to track my expenditures? Or is it a tax system that I'm trying to file my taxes with? All of these applications perform a business function, and for each of those functions, there will be a different set of attributes which define me as a user that's relevant to that application. For example, Amazon will want to know my credit card number and my physical address, so when I buy something, they know what to charge and they know where to send it. A tax system will want to know my yearly income and maybe a tax identification number so they know how much taxes to charge me, right? These attributes still define me. I am the same person depending on the application that I'm working with. Those attributes, otherwise called a digital identity, will be different. A digital identity is a specific set of attributes that define me within the scope of a given application. The application should use those attributes while performing its business function on my behalf. Let's say yesterday I connected to this web application and I entered in all of my attributes into the system, right? And then today I come back to the application. How does that application know it should use the attributes that I entered yesterday versus maybe one of my colleagues, right? And the oldest solution in the book, obviously, is username and password credentials. Between the application and myself is an agreement for a shared secret, right? Something that I and only the application know. I will provide the secret to the application to reassure it that I'm the same person that showed up yesterday and created the account effectively, right? And that the application should load up my digital identity and use that when interacting with its data. Both username and passwords are used to allow some flexibility around the changing of the password. If all I was doing was providing the secret, when I wanted to change the password, I'd have to reassociate all the digital identity values with that new password. So instead, we have a username, all the attributes are associated with that, and then we have the shared secret, which can change whenever it needs to. The combination of the username identifier and the shared password secret prove my identity to the application. The fact that I know the password proves I am the person that signed up to the app yesterday. At a minimum, I need to present both my username and password every time I sign in. The application needs to store both my credentials and my digital identity in their data store in some way, right? So they've got, in their system somewhere is a table that's holding my username and my password, and maybe some kind of attributes or collections of attributes tables are stored in their system. The username and password is the simplest form of this authentication that I can think of. And it's easy enough to implement. Most application frameworks like Rails or ASP.NET come with this functionality out of the box, right? In fact, I can't think of a modern framework that we're using now that wouldn't have some implementation of this that's available to you. And most books that you get on beginning software development, especially back in the day when I started in the mid-90s, you get those big, giant red rocks books that were kind of bricks. I had a whole collection of those, and every one of those books walked you through setting up username and password-based authentication. Right, everybody does that. They've implemented it at least once. Everybody implemented username and password at least once, like by hand, just as a demo, not necessarily professionally. Right, it's a very common thing.